In this tutorial, we will guide you through setting up two similar PBXs using the anynode scenario wizard, with a focus on port and SIP transport sharing. Additionally, we'll demonstrate how to manually configure port sharing in an existing setup. This process will help you learn how to locate and modify the correct settings within the anynode object structure. To configure two similar PBXs, we'll use the new SIP transport option in the wizard, allowing both PBXs to share a single SIP transport. This setup ensures that both PBXs are accessible via the same port. The selection of which node to use is determined by a customizable whitelist in the SIP node object or by the transmitted local SIP domain. It's also possible to have multiple similar PBXs share a single SIP transport. For simplicity, we will first show the wizard-driven setup using the scenario wizard. In practice, it's more common to manually configure the nodes. Note that the wizard currently only supports routing through the whitelist method in the SIP node object. Before we begin the configuration, let's review the automatic entries that the wizard makes in the anynode object structure. This is crucial if you later need to set up port sharing for an existing configuration or make changes to the whitelist. The diagram shows that the call comes in from the right, from one of the two PBXs, with both nodes using the same SIP transport and, therefore, the same port. For security reasons, the SIP transport should have a shared whitelist that includes the IP addresses of both peers. However, this is not strictly necessary for the port sharing to function. After the SIP transport, the call is routed either to the PBX1 node or the PBX2 node. The decision on which node to use is determined by the configurable whitelist in the SIP node object. For PBX1 node, the IP address of PBX1 must be entered, and for PBX2 node, the IP address of PBX2 should be listed. If you're new to any node, we recommend watching our tutorial video, First Steps. We'll begin by using the scenario wizard. The scenario wizard assists you with common installations by providing pre-configured system profiles and SIP providers, allowing for quick and easy setup in just a few steps. Click on Wizard in the top left menu. In our example, select the scenario, create relationship between two PBXs or voice over IP systems. Click Start to proceed. Click Configure to set up the first PBX. Choose a PBX from the list. The Node Interconnection Assistant provides a list of pre-configured profiles from well-known manufacturers. In our example, we select the profile Innovaphone. Click Next to continue. The Node Assistant for PBX and other voice over IP systems now includes a SIP transport menu item. Here, you're asked whether to create a new SIP transport, which can later be used by other nodes. You can also select an existing SIP transport from a previously configured node. In our example, we'll create a new SIP transport for the first PBX, which we'll later share with the second PBX. Enable the option, this SIP transport will be used later from other nodes. You can optionally enter a custom name for the shared SIP transport. For this example, we'll use the name suggested by the wizard. Click Next to proceed. When configuring the network controller, you have the option to specify a fixed IP address, use the IP address of a network card, or perform an advanced configuration. Additionally, there's an option to use an already existing network controller. In our example, we'll select our network card so that the node communicates using the associated IP address. Click Next to proceed. Next, define the ports to be used for the PBX's SIP signaling. In our example, we'll use the default values automatically provided by the wizard. Generally, default values are grayed out, and unless you unlock and modify them, the default settings will remain active. Click Next to proceed. In the SIP interconnection step, you'll decide how to connect to the PBX. Typically, you have three options: node interconnection via SIP trunking, node as SIP registration client, and node as SIP registrar. In practice, PBXs often work with direct peer-to-peer SIP trunks. In these cases, you usually just need to configure the IP address or FQDN of the peer in any node. For this setup, you would select the SIP trunking option. In our example, we will use this method and choose the first option. Click Next to continue. In the remote SIP domain field, enter the IP address where the first PBX is reachable. We recommend using the input assistant by clicking Edit. The SIP prefix will be added automatically. Click OK to exit the input assistant. The entry for the remote SIP domain is now added, and the wizard will automatically insert the IP address into the shared whitelist. Click Next to proceed. If the remote side requires authentication, enter the authentication credentials under Client Authentication. Click Next to continue. The network peer whitelist is a crucial security feature that allows communication only between the selected PBX and any node. The peer can be specified in the whitelist using an IP address, a hostname, or SRV records. As a result, only network packets from IP addresses listed in the whitelist, or those that resolve to these IP addresses, are accepted or sent. Packets from other IP addresses are blocked. The network peer whitelist will later be shared with the other PBX and is therefore created as a shared network peer whitelist. The assistant has automatically entered the IP address from the remote SIP domain. If a single SIP transport object is used for multiple nodes, incoming calls can be filtered using this shared network peer whitelist. The assistant will later add the second PBX to this shared network peer whitelist automatically. No further action is required from you, you can simply click Next. In the SIP node network peer whitelist, the assistant has automatically entered the IP address of the first PBX from the remote SIP domain. Based on this entry, calls will be routed to either PBX1 or PBX2 through the shared SIP transport. No further entries are required from you. Please click Next to proceed. In our example, we do not need to use incoming rewrite rules for number rewriting. If needed, refer to our tutorial video on basics of dial string rewriting and routing for more information. Click Next to proceed. We do not need to use outgoing rewrite rules for number rewriting in our example either. Click Next to proceed. The name of the node can be chosen freely. We change the assistant's suggestion to PBX1. Click Finish to complete the process. The node interconnection assistant now displays an overview of the configured PBX1. Click Next to configure the second PBX. We are now in the configuration menu for the second PBX. Click Configure. Select the second PBX from the list, just as you did with the first PBX. Click Next to proceed. For SIP transport, you need to select the existing SIP transport that was configured for the first PBX. Choose the second option, select an existing SIP transport and then select the shared SIP transport. Click Next to proceed. Repeat the following steps for the second PBX, as you did for the first PBX. For the remote SIP domain, enter the IP address of the second PBX. This IP address will also be automatically added to the SIP node network peer whitelist by the assistant. Adding the IP address of PBX2 to the shared whitelist occurs automatically in the background and is not prompted by the assistant. We change the suggested name to PBX2. Click Finish. You will now see an overview of the configured second PBX. Click Next to proceed. For routing, we allow all calls to be forwarded to both PBX nodes based on the destination URI without any restrictions. The routing will then be handled as previously explained, using the whitelist in the SIP node object. Select the top option, use direct routing without prefix filter. Click Finish. Don't forget to finalize the configuration of the PBX nodes by clicking Commit. Let's briefly review the objects where the assistant automatically applied the settings. No further adjustments are needed from you. Click on the SIP node object for each PBX node and navigate to the Settings tab. In the SIP node settings for each PBX, an incoming call can be assigned to a specific node. At least one of the following two criteria must be met. Match with the local SIP domain. Match with the initial invite message in the network peer whitelist. You can find the shared whitelist in the SIP transport object. Navigate to the Network tab and check the entry under Network Peer Whitelist. Here, the assistant has added the shared Network Peer Whitelist for both nodes. Additionally, the ports are the same for both nodes. Switch to the SIP User Agent object and open the Object tab. Here, you can see that the assistant has automatically assigned the shared SIP transport to both nodes. Switch to Monitor mode. In the dashboard under SIP nodes, check the correct operation of both PBX nodes. By clicking on a node, you can view additional details such as port information and options packets. You have now successfully configured two PBX systems that are accessible via the same port and share a SIP transport. Setting up port sharing in existing configuration. It is possible to set up port sharing in an existing configuration with two or more similar phone systems, and manually configure the port sharing settings that the wizard would have applied when using a scenario. In our example, we have two similar PBX systems without port sharing, and we now want to add port sharing retroactively. Currently, each PBX node has its own SIP transport and network controller. With the retroactive setup of port sharing, both nodes will use the same SIP transport and, therefore, the same port when a call from either PBX enters any node. For security reasons, a shared whitelist should be configured in the SIP transport, containing the IP addresses of both PBXs. However, this is not strictly necessary for port sharing to function. After passing through the SIP transport, the call will be routed either to the PBX1 node or the PBX2 node. The decision on which node to use is determined by the configurable whitelist in the SIP node object. Here, the IP address of PBX1 must be entered for the PBX1 node, and the IP address of PBX2 for the PBX2 node. We will now begin the configuration. We recommend starting with renaming the SIP transport for PBX1 to improve clarity later on. Click on the PBX1 node and navigate to the SIP transport object. Open the Object tab. Change the name from PBX1 to Shared PBX. In the PBX1 node, navigate to the SIP node object and open the Settings tab. Enable one or both of the options under Only accept incoming calls on shared SIP user agent objects. At least one of the following two criteria must then be met. Match the local SIP domain. Match the initial invite message in the network peer whitelist. In our example, we want the initial invite message to match the network peer whitelist, so we will enable the second option. You will need to apply the same option in all other nodes that will participate in port sharing. Now, click the plus to add a SIP node whitelist that includes the IP address of the corresponding PBX. Name it Network Peer Whitelist PBX1. Click OK. Edit the newly created whitelist by clicking the pencil icon. You will now enter the Network Peer Whitelist object for the PBX1 node. Click Add. Enter the IP address where PBX1 is reachable. Click Finish. Switch to the PBX2 node and repeat the corresponding steps. For the PBX2 node, be sure to enter the IP address where the second PBX is reachable. Now, stay within the PBX2 node and go to the SIP user agent object. For each node that will perform port sharing, the same SIP transport must always be set. In the Object tab, we set the SIP transport for our example to the PBX1 node, which we previously renamed to Shared PBX. Stay in the PBX2 node and switch to the Media Negotiation object. Open the Object tab. Change the network controller from PBX2 to the shared controller. Stay in the PBX2 node and switch to the SIP transport object. Open the Network tab. In the Network Peer Whitelist section, edit the shared whitelist with the pencil. If you prefer not to use a shared network peer whitelist at this stage, you can skip this step. The shared whitelist is not strictly required for the core functionality of port sharing. However, we still recommend using a shared whitelist. To edit the shared whitelist, click the pencil icon. You will then be directed to the Network Peer Whitelist for SIP transport. As previously instructed, add the IP address of the second PBX using the add function. The IP address of the first PBX is already included. Afterward, you will see an overview displaying both IP addresses. Despite setting the SIP transport for PBX node 2, the old SIP transport is still active and listening on the configured ports. For security reasons, we recommend deleting the old SIP transport so that the ports can be used for other configurations in the future. To do this, navigate to the Auxiliary Objects section in the left menu. Scroll down to SIP transport and select the SIP transport that is no longer needed, in our example, PBX2. Click Remove SIP Transport. The Remove Object Graph Input mask will appear. All old PBX2 objects are now ready to be removed. Click Remove. Apply the changes by clicking Commit. Briefly check the functionality of both PBX nodes and switch to monitor mode. In the dashboard, each node should show a green status. Click on one of the PBX nodes to view additional details, such as the exchange of options packets. Each PBX node should now be using port 5060. Congratulations, you have now learned everything important about port sharing.